Okay, I thought I'd go through this second half of section 3.3. We left off here. We're going to start with percentiles. It's a measure of location. It's denoted by p sub 1, p sub 2, whatever percentile you're looking for. So the 75th percentile would be p sub 75. And if we want to find the percentile of a data value, so we have some data here. We want to know what percentile is, say, the value of 10. Well, the percentile of a value of any value is the number of values less than it. So how many are less than it over the total number of values, and then just multiply by 100 because this will be a decimal, and we make a percent. So we look at where 10 is located, and then we count the numbers less. 1, 2, 3, 4. There's 4 less. There's 1, 2, 3, 4, 5, 6, 7 values. So we take 4 and we divide it by 7 and get 0.5714, or 0.57 rounded off times 100, 57%. And that's a very approximate because there's not a lot of data here, and if you were to, find exactly where that is, it's probably not exactly, but this is an approximate way. We're probably going to be finding the 25th percentile, or the 50th percentile, or the 75th percentile, rather than finding what percentile is this value. So if I scroll up a little bit here, you'll notice it says find the 25th percentile. Well, there's a little bit different formula for that. The 25th percentile is what we're looking for. So what value fits that? Well, we create this formula here, where we have k over 100, and k is whatever percent we're looking for, so the 25th. So we put in a 25 over 100 and multiply by how many values we have? 7. And then we just multiply that out. So the 25 over 100 is 1/4, right? Times 7, or 7/4, and that equals 1.75. So it's saying the 1.75 spot is the 25th percentile. 1, 2, so it's in between 3 and 5, and we can't really get it, but we could round it up to say it's 5. Because otherwise we have to do some math and try to find what's 0.75 of the distance between 3 and 5, right? It gets pretty complicated. And so there isn't always an exact agreed upon method in statistics on how to find percentiles. Let's look at this article here that I have from an online stat book. It actually shows an example of some test scores. They rank them, and they have numbers 3 through 15. And it's defined here as P, which is our K, divided by 100 times not only n, but n plus 1. And so then we get this 2.25, and so it shows that it's 2.25, and they go ahead and try to find out what that 0.25 is. So between 2 and 3 is 7 and 5. And so down here at number 4, they take 7 minus 5 to get that difference of 2, and then they multiply that difference by 0.25 to find out what is 0.25 of 2. They add it back onto the 5, and then they get 5.5. So that's more of an exact way to find the percentile. So the 25th percentile in this case would be 5.5 between these two numbers. We're lucky enough to have statcrunch, so we're going to use statcrunch on our values. So here I have my numbers 5, 6, 8, 10, 12, and 15, and I want to find the 25th percentile. All I do is I go into statcrunch and go into summary stats and column. My data is what I have here, and then you just scroll down here to where it says percentiles. You enter whatever you want, the 25th percentile, and then we click compute and get rid of everything else. I'll just hit N here. It comes out to be that 5 is the 25th percentile and 7. So we had that 5 also was the 25th percentile. We rounded up and it gave a 5. So it's doing very similar to what we're doing versus going in there and finding the 0.75. So there's not an agreed upon way. multiple answers in my method will be correct, we'll use statcrunch to figure that out. But what you're doing is you're finding a 25th percentile. If you want to find the 50th percentile, you put it in there. If you want more than one, put a comma. You get all the ones you want, 8 and 12. So 5, 8, and 12, which would make sense because they're evenly distributed across our data. Now I want to look at box plots, and you're going to find out that they include these percentiles. So this whole thing here is what we'd call a box plot. It's showing a few things. It's showing the 25th percentile of the data, and that would be the end here. It's showing the 75th percentile, quartile 3, and it ends here. It's showing the median, or the 50th percentile. The median would be the middle value, right? The middle value of everything. Then it has these what we call whiskers coming off. They come off the side and they go to this point here. And they come off the side and they go to this point here. Now that point is calculated by this. We call this the minimum. It'll be the quartile 1 minus 1.5 times the interquartile range. And this would be the maximum. It's quartile 3 plus 1.5 times the interquartile range. What's the interquartile range? It's the quartile 3 minus quartile 1. So it's the difference between these two up here. So basically, you grab all the quartiles, you grab the medians, and then you graph those items, and then you see if there's any outliers that are outside of that fence that they call it. They call it a fence, and you see if there's any that are outside of there, and you can put dots there to show your outliers. I have a video here that shows more about how to quickly do it in statcrunch. I'm going to do it by hand here. So just some definitions again. Q1 is quartile 1, it's the 25th percentile. Q2 is the second quartile of the 50th, or the median, same thing. And quartile 3 is the 75th percentile. They call this the 5-number summary of a box plot. So if we look at this, they have 5 things. You want the minimum, the first quartile, the second quartile, the third quartile, and the maximum. Now there's a couple different ways you can make your box plot. One is the whiskers extend all the way out to the minimum values. And that's why they want the minimum and the maximum. The other way is that they extend just to this calculation of the minimum so that you can see your outliers. Because the outliers are considered to be past this, to the left of that one and to the right of this one. So you might see one where they don't put the outliers in, and it would just be a box plot that looks something like this, and it goes out and shows how far the minimum and maximum are. And there won't be any outliers. It goes to the minimum value and the maximum value. So it depends on if they want you to show the outliers or not. If they want you to show the outliers, you calculate this value, and then you show your outliers. Let's create our own box plot here with our data. This data here is the temperature data. And if we look at it, there are 20 data points. We count them all up, there are 20 data points in here. And we're going to create a box plot by hand. So we need to figure out Q1, Q2, Q3, Q, and the median, the IQR, and then we just draw it. Now remember, the Q1 is actually the 25th percentile, the 50th percentile, the 75th percentile. The IQR, the interquartile range, is just Q3 minus Q1. So we'll be able to get that once we get our first values. Now there are a few ways to get our 25 percentile. We could just count them, right? And do it ourselves. Do the 25 over 100 times the 20 and count them up. But I think I'm going to show you how to use statcrunch to be consistent with our values here, and just use what it gives us. Alright, so here's our information right here, the temperature. So I go over to statcrunch, and I summary stats on the column, and I'm going to choose the temperature. Now in here I just want a few things. There's a few things in here. I can get it all. The Q1, the minimum, the maximum, Q3. There's a median in here somewhere, median. So the median is Q2. And then we also want, if we want to put them in here, we can just do them in here. 25th percentile, 50th percentile, 75th percentile, right? You can just put those percentiles right in there. But they're basically all right here. Q1, Q2, Q3, mid and max. I click compute. I get some information here. So my Q1 is going to be 68. My Q2, which is my median as well, you'll see that 50 percentile and the median match up as 70. My Q3, 72.5. That's a little bit, and 75th percentile, 72.5. So that one's where it gets a little weird, because if you look at our data, we don't have a 72.5 in there, right? So they're going in between these here. But that's okay, we're using statcrunch and it is a valid answer. Alright, so let's find our interquartile range. Q3 is 72.5 minus Q1, 68, 4.5. So that's our IQR. So before we draw the box plot, I think I want to find out how long the whiskers are supposed to be. They're supposed to be Q1 minus 1.5 times IQR. So let's do that minimum, since we're not going to use the minimum from the data list, 60 and 8. The 60 is the minimum and 80 is the max. Let's try to find if there's any outliers. So we will want to use this to do that. So the Q1 would be 68 minus 1.5 times the IQR, which is 4.5. And then let's find the maximum, 60, or Q3. Q3 is the max, so Q3 would be 72.5 plus the 1.5 times the 4.5. And I'll use a calculator to do this. 61.25, 78.75. Okay, now let's look at this because I can't have it on the same screen. But we're going to draw Q1 and Q3, and that's going to be our box. The median will be where it is in the middle. We'll try to match it up where it is. It doesn't have to be exactly in the middle of this box. It has to be in the middle of those two numbers, right? Or wherever it falls in the middle, wherever it falls between those two numbers. And that would be the IQR. So let's make the box. 61 point, let's see, the Q1 is 68. The Q3 was 72.5. And then the median, the 50% or Q2 was 70. So you see where 70 is. Let's try with a blue one. So 68 is 2 from there, and it's a little more, it's almost in the middle, but it's just slightly over right there because of the 0.5, right? That's where the median is. So the median is the middle of the data set, but it has to be the middle of these two values, so it's 70. Okay. Now we're going to draw our whiskers out to our minimum and maximum, which are calculated with these values. Our minimum was 61.25, so I'm going to draw a whisker out to 61.25. And I'm going to draw a maximum out to 78.75. About 6 units there, 6 or 7 units there, so about the same. You want to make sure these whiskers are what they should be in terms of the units, right? 78.75. So they're about the same. This is about 6 units, and this is about 7 units. So this side's a little longer. Okay, so we got that part. Now we just need to see if there's any outliers. We're pretty much done. We're looking for now our outliers. Are there any values that are less than 61.25? Yes. 60. So let's put that on there, right about there. And are there any values greater than 78.75? Yes. 80. And that one's probably right about there. 60, they're about the same, aren't they? So there's our box plot. This is the IQR up there, and there it shows the data with the spread. Now, if we did not want to include the outliers, the only difference how our box plot would look would be like this. Draw the rectangle, draw the median. I would make the whiskers come all the way out to the minimum and maximum. And that would be the difference. This one doesn't show the outliers. This one up here shows the outliers. So a lot of times you just check to see what it's looking for. I like to have it where it's showing the outliers if there are any. It's very easy to do. Now let's look at how to do this in StatCrunch. All we do is we take our data, temperature, graph, box plot, temperature. Now here it is. Use fences to identify outliers. Yes, we can have it on so we can see them. If they don't want it on, you'll see the question doesn't have any outliers. On the homework, just click it off. Do this one, draw the box horizontally. And then that's all we need to do. I can't bring it up here. Let's see. Compute. And there we go. You'll notice how they've put the temperature on the bottom scale. 60, 65, 70, 75, 80. If you hover over here, you'll see your values. Got 20 of them, 2 outliers, 4.5, lower limit, upper limit. So it's a little different than what we have. We had 61.25 because we did the calculation, but the lowest data point that fits that is 65. And then the other way, the highest data point that fits that is 78 versus our 78.75, so that's where they stopped. They stopped at the data points. Now if I go in here and also remove the identifiers, compute, now you'll notice it just goes from the minimum of 60 to the maximum of 80. And you'll notice that that median is just slightly to the left, right? 68 here, they have the quartile 1 median of 70, quartile 3 is 72.5, so it's a little left. So both of these work. They're both box plots. They both show the middle 50% of the data from 25% to 75%. They show how spread out the data is, right? But one will also show what they consider outliers. And by clicking that button there, you can see that. Okay, so I hope that helps kind of with the box plots and the percentiles so you can continue on with your homework.